This video will cover the problems in the Unit 3 review. So we have a monomial inside this parenthesis and a monomial inside this parenthesis, and we are multiplying those together. But we first have a power of a power right here. So this 3 on the outside will distribute into the number 2, the exponent of 3, the exponent of 3, and the exponent of invisible 1 on the z. So how we'll rewrite this is 2 to the third power, and then x to the 3 times 3 power, y to the 3 times 3 power, and then z to the invisible 1 times 3 power. So then we further simplify this line. 2 to the third, remember, means 2 times 2 times 2. And then I've got x to the 9th, y to the 9th, z to the third. So then the last line, 2 times 2 times 2, gives me 8, x to the 9th, y to the 9th, z to the third. And so that was just simplifying that first monomial of a power to a power. So then we have this second monomial. So we have x to the 5 times 5 power, because this 5 distributes to the 5, the exponent 5, and distributes to the exponent of invisible 1. So then we have y to the 1 times 5. So when we simplify that, we have x to the 25th, y to the 5th. And so I'm going to rewrite that in this same color just to keep it consistent. And now all of these, what's happening is it's multiply. So now that I have all of the outside powers taken care of, the next step is to then multiply. And I just have one whole number, so that 8 will just stay 8. And now I'm multiplying the base of x to the 9th and x to the 25th. And because they have the same base, now we are adding those exponents. And then I have y to the 9th plus that 5, and then z to the third. So my final answer when it's all simplified is 8 x to the 34th power, y to the 14th, z to the third. So that is the final answer. So on number 2, we're still simplifying, but we actually have this fraction bar which indicates divide. So I'm going to divide the big numbers. So 10 divided by that -2 is a -5 over 1. And then I have r to the 5th and r to the invisible 1. So I'm going to write that on top, r, and it's going to be 5 minus 1. So it's top exponent minus bottom exponent. And then for the t, I have t to the invisible 1, because that's the top exponent, minus 5. And then for the z, we have z to the 6th minus 4. So then as I work down the page, I still have my -5. over 1. And now r to the fourth, t to the negative fourth, and z to the second. And one of the rules of exponents is that we cannot leave negative exponents in our answer. So negative 5, r to the fourth stays on top of the fraction. On bottom of the fraction, this t to the negative fourth moves to the bottom of the fraction, and the negative 4 changes to a positive 4, and then the z to the second stays on top. So my final answer would be negative 5 r to the fourth z to the second over t to the fourth. On number 3, we have a binomial, then we have a minus sign, then another binomial. So the first thing we'll do is rewrite the first binomial without parentheses. Then the second trinomial, because we are subtracting, we have to distribute this negative sign to all 3 of these terms. So what we have is a negative or a minus negative. So that would be plus 4x to the fifth. And then we have minus a negative, so plus 3x. And then minus the positive, so minus 6. And then once we have everything written without parentheses, we put like terms together. And generally we start with the largest exponent, so that would be 4x to the fifth. Then we don't have an x to the third, but we do have an x to the second, so plus 6x squared. And then I have a positive 2x and a positive 3x, so plus 5x, and then minus 6. And so that is the final answer. And what people will forget is to distribute that negative sign into all the terms that come after it in the parentheses. Number 4, we have a trinomial inside the parentheses, a plus sign, and then a trinomial inside the second parentheses. So we are going to write everything without the parentheses. And because this is a plus sign, we don't have to change any of these signs inside. So it's just plus 5x cubed plus 8x squared minus 14x. And then we'll start putting like terms together. Starting with the highest exponent, I have 5x to the third plus 5x to the third gives me 10x to the third. And notice that those exponents do not add together. It's because we have pluses and minuses in between all of our terms. And then we have squared terms. So negative 2x squared plus 8x squared would give me a positive 6x squared. Then I have 6x minus 14x, so minus 8x. And that is my final answer. Number 5 is a FOIL problem because there is no plus or minus sign in between the parentheses, so we know it's FOIL. So we're going to take the first 2 terms and multiply those together. So 6x times 6x would be 36x squared. Then we will take the outside terms, 6x times 4, so plus 24x. And then the inside terms of 4 times 6x is plus 24x. And then the last terms, 4 times 4 plus 16. So now we're ready to combine like terms. 36x squared does not have another term to go with it. 24x plus 24x, those combine to make plus 48x. And then the 16, so plus 16. And this is my final answer. So this is number 6 in Math Excel, but it's number 7 on the paper packet. So when you have a quantity squared like this, the first thing you have to do is to rewrite it as 2 parentheses. And then we're ready to FOIL. So our first 2 terms, 4x times 4x, 16x squared. Outside terms, 4x times negative 9, so negative 36x. Negative 9 times 4x minus 36x. And then negative 9 times negative 9 is positive 81. We add like terms together, and so 16x minus 72x plus 81. And that is our final answer. Number 5 is another multiply problem because we don't have anything in between the parentheses. And it's not really FOIL because I have 2 terms here and 3 terms here, but it's a form of FOIL. I'm going to take my first number times the first number in my second parentheses. So 9x times 2x squared would be 18x to the third. Then 9x times 4x gives me plus 36x squared. 9x times 6 plus 54x. So now I'm finished with the 9x, and I'm ready for the 5. So now 5 times 2x squared would be plus 10x squared. 5 times 4x would give me plus 20x. And 5 times 6 gives me plus 30. And now I'm ready to combine like terms. So my highest exponent is x to the third. So 18x to the third. Then I have a squared term and a squared term. So 36 plus the 10 gives me plus 46x squared. Then I have a 54x and a 20x, so plus 74x, and then my 30. So plus 30. And that is the final answer because it's completely simplified. So number 8 is a factoring problem. The very first thing we do when we factor is to look for a greatest common factor. So we're going to look for a greatest common factor, and there is one. Each of these terms has an x in it. So x, and then x to the third divided by x would be x squared. Negative 4x squared divided by x is negative 4x. And negative 21x divided by x is minus 21. Now that we have the greatest common factor, we look and see what's in the parentheses. Well, that's a trinomial. So when we have a trinomial, we generally split the middle. So I'm looking for factors that multiply to negative 21, but add to negative 4. So I'm going to have 1 times negative 21, 3 times negative 7. And so that's the one that works. So I have that x, and then this trinomial gets rewritten as x squared plus 3x minus 7x minus 21. And we cut it after the second term. The greatest common factor is x. So x squared divided by x is x. 3x divided by x is plus 3. Each of these will divide by negative 7. So negative 7x divided by negative 7 is x. Negative 21 divided by negative 7 is plus 3. So just this part is x plus 3 times x minus 7. But then remember at the beginning, we had that greatest common factor. So our answer will be x times x times x plus 3, x minus 7. So this is another factoring. So we look to see if there is a greatest common factor. And there actually is. 3 can go into each of these. So 9m squared divided by 3 is 3m squared. 30m divided by 3 plus 10m. Negative 24 divided by 3, negative 8. So I have a trinomial in here. So I need to find factors. That multiply to negative 24, because I have to multiply that 3 times that negative 8, but they add to 10. So negative 1 times 24, negative 2 times 12. Well, there we go. I found it. So now we have 3, and then my trinomial splits into 3m squared minus 2m plus 12m minus 8. Cut after 2. Greatest common factor is m. So 3m squared divided by m is 3m. Negative 2m divided by m is minus 2. So here we're going to divide by positive 4. So 12m divided by 4 is 3m. Negative 8 divided by 4 is minus 2. So then this becomes 3m minus 2 times m plus 4. And then we can't forget about the 3 that we originally had. So our answer is 3 times 3m minus 2 times m plus 4. When you have two terms inside the parentheses and you're asked to factor, you want to see if you have a difference of squares. And so if I come over to the side, and if I take the square root of 25y to the 4th, I would get 5y squared. If I take the square root of 36, I get 6. So yes, each of those are a perfect square. So that means that I can factor this binomial into two factors. One will have a plus, one will have a minus. So we just found out that the square root of 25y to the 4th is 5y to the 2nd. So that goes in the first position of each parenthesis. And then the square root of 36 is 6. So that goes into the second. And these cannot be factored any farther because there's no greatest common factor. They're not a difference of squares. So this is factored as far as it can go. Number 11, you are asked to factor. Okay, number 11, you're asked to factor It already has 4 terms, so we just split after the second term. And the greatest common factor would be x squared for the first two. So we've got x squared. And then x to the third divided by x squared would be x. 5x squared divided by x squared is plus 5. And then on this side, 8 will go into both of these, so that's plus 8. 8x divided by 8 is x. 40 divided by 8 is 5, so plus 5. And then I have x plus 5. And what's left over is the x squared plus 8. And I have a squared term, but I don't have a difference, and these aren't perfect squares, so this is the final answer.